So, okay, students, let us see this problem. A particle of mass 1 kg has a velocity of 2 meters per second. A constant force of 2 newtons acts on the particle for 1 second in a direction perpendicular to its initial velocity. In a direction perpendicular to its initial velocity, it is important to find the velocity and displacement of the particle at the end of 1 second. He is asking. So here the direction of perpendicular to its initial velocity means the acceleration and the velocity directions are perpendicular each other. Let us take the initial velocity in this direction, initial velocity u, and the force acting particle force direction in the net force direction, the acceleration direction is also there. So the acceleration direction is in this direction. So both are perpendicular. So this is motion in a plane. So we should use vector forms. We should use vector formula to solve this problem. Let's say first of all the mass m is equal to given 1 kg and the force F is equal to 2 newtons. Then the acceleration A is equal to F by m, that means 2 by 1, that is equal to 2 meters per second square. This is the acceleration. Initial velocity u is equal to initial velocity 2 meters per second. Initial velocity and acceleration is there. And the particle for 1 second. Find the velocity. Time intervals are t is equal to initial time is 0 to 1 second, right? Find the velocity and displacement of the particle at the end of the 1 second. Velocity is asking. So final velocity v is equal to, here v bar is equal to u bar plus a bar t. Why we are using this? Since this is a motion in a plane, we are using a vector form. So is equal to u is how much? So here the velocity component is asking velocity, the modulus of the velocity, magnitude of velocity is root over the both are since they both are perpendicular, the magnitude is u bar modulus u bar square plus mod a bar t square. Right, that is equal to, you see, u bar is 4 plus a t is equal to 1 second is given. T a means here 2 square means 4, that is equal to 2 root 2 meters per second, the magnitude of the velocity. And here the direction also to be mentioned. How can you find the direction? That means the angle theta is equal to tan inverse modulus of a bar t by v bar. So that is equal to tan inverse 2 by 2, that is equal to tan inverse 1, that is equal to 45 degrees. So here the velocity, final velocity v is after 1 second it will making an angle of 45 degrees with the initial velocity direction. So here the magnitude of velocity is equal to 2 meters per second is making an angle of 45 degrees with the direction of initial to the direction of initial velocity. So this is one. And secondly, what he is asking here, he is asking displacement of the particle. Displacement. So displacement. Secondly, displacement is asking. Displacement S bar is equal to u2 plus half a t square u bar t plus half a bar t square. So modulus of s power is equal to square root over since they are both are perpendicular, the magnitude is u bar t whole square plus half a bar t square whole square. That is equal to u means here 2 into 1 2 square is equal to 4 plus a is equal to also 2 can say 1 cancel. A is equal to here how much is given 2 are cancel. T is equal to 1 second, that is equal to 1 till root 5 meters is the displacement after 1 second. And a displacement vector angle also should be find out. So the angle theta is equal to tan inverse of a square t square by u bar t that is equal to tan inverse 1 by 5. U is equal to 1 by 2. So tan inverse 1 by 2 is the angle. So here the magnitude of displacement is equal to root 5 meters, making an angle tan inverse by 2 with the initial direction of initial velocity. Thank you.